Hello everyone, welcome to the Code Deep Dive series. This is episode 4. So today we will already solve an interesting problem called minimum number of seconds to make mountain height 0. So in this problem we have a mountain with a certain height and multiple workers who can reduce mountain height, and each worker can reduce any amount of the mountain, but time taken increases with each unit reduced, and the time for each unit is multiplied by the worker speed, and also all workers work at the same time, and the total time is the maximum time taken by any worker. So our goal here is to split the work among the workers so that the maximum time is as small as possible. So we can already summarize this problem, to avoid read everything. So, and to avoid also extra minutes. Yeah, we have already a mountain of height called h, for example, and there are n workers. Each already with the time factor worker times of I, and the time for worker to reduce k units is, we can say, worker times of I multiplied by 1 plus 2 plus until k equal worker time of I multiplied by k plus 1, so on, divided by 2, and all workers work simultaneously, so the total time is the maximum time any worker takes, and we want to minimize this maximum time. And also we can this is problem, my insights here, or my insights here, we can this problem can already say the problem is about dividing the total work each among workers to minimize the maximum time, and triangle split is impossible due to large input size and so on. So we, as you can see here in the hint, we can use binary search to solve this problem. This is already simple techniques to do that. The problem, we can guess a time t and check if the worker can finish the mountain with t to seconds or not. If yes, I will try smaller. If no, I will try larger, and so on. And I think for each worker you can calculate the maximum units k they can reduce within time t, and we can also use the quadratic formula to find the k. And we can sum all k values. If sum greater than or equal h, we can guess this is a guess here t for t is visible, and so on. We can already, for a just binary search, you can narrow down the search range until the mountain visible time is found. Okay, this is about the problem. It is really classified as a medium problem, but it is easy. We can starting with it, and if we have anything, we can already leave the comment. Okay, so we can starting with the find the slowest workers time factor, and after that we can set binary search boundaries, and we can after that already working on already and guessing the time until already calculate max units k using quadratic formula as we mentioned. So let's starting with the find the slowest workers time factor. I think we can do it max time factor. This is when, sorry, this we can do it by max element. Yeah, okay, max elements here will take the worker times this one, workers time dot begin, sorry, dot begin, and workers time dot end. This first one get now our slowest workers time factor. This is max element. Okay, so we can already set binary search boundaries long so okay, left. This is by 0, and we have also long right. This is will be, by we can already multiply max time factor by mountain height plus 1 until divide by 2. This is equations. Okay, and don't worry about it. So we can max time factor this one, max time factor this is one, and multiply by max time factor plus 1. Okay, Yes, max time factor, yes, +1. Yeah, I think we can also divide here by mountain height first, then by, yeah, by mountain height, not mountain height, yes, not maximum, max time, mountain height +2 until divided by 2. I hope this is will be, yes, this is max time factor, mountain height +1 divided by 2. So our long answers here, long answers, and I will set it by right, and then we can go to inside the our boundary, and so as long as left is an or equal right, I will go to until catch everything. Okay, this is first thing. We can now calculate our mid, long mid. This mid will be left plus right minus left, right minus left divided by 2. This is our mid. Everyone know how can we do that. And long total units. Yes, total units. Yes, sorry. For that total units here, we can this total unit reduced by all workers. Okay, and now then we can do this is one. Sorry, yeah, long total units. I need you now to iterate, yeah, over worker times. This one I need inside the loop to make the for int I, for examples, or t not I, over the workers times. Okay, and after that we can do something like yeah, after this iteration I will calculate the work, max work this worker can do in mid time. Long work, this is mid by t, and after that I will do calculate max unit k using quadratic formula. So long k will be the, yeah, square root for 1 plus 8.0 plus multiplied by worker divided by 2. I will already explain this is, yeah, after after that, yeah, we can take calculate formula minus 1.0, yeah, plus a square root of 1 plus 8.0 multiplied by work. Yeah, and yeah, I already tried with something, but I will tell you where this equation come from. So this is 2.0. Okay, this is our equation. Let's tell you why this equation exists. This is static cost also. Yeah, let me tell you now. This one is the long, and this is minus 1.0. I need to just open this one and close it here. Okay, yeah, let's now explain why this already exists. Yeah, now we can say already this numbers already, for example, this -1, this is already comes from formula to solve a quadratic equation, and the 1 plus 2 work is inside the square root because it is a part of calculation called discriminant, and these numbers come from the mass formula used to find the maximum units a worker can do in the given time. Yeah, you can check it about this quadratic equation, you will get it. And also related to, yeah, we use the formula to solve the equation k power 2 plus k minus 2 times and so on. Yeah, this is already equations, yeah, popular equation. And so -1 and 1 plus 2 work as just part of the standard quadratic formula. Okay, yes, let's continue now. Yeah, after do that I will sum this where the k, yeah, total units, not total units plus equal k. Okay, then yeah, after that I will already check if total units greater than mountain high or not. Okay, if total unit total units, yes, total unit, if the total unit is greater than, yeah, or equal this mount height. Okay, what can we do now? If enough units we if enough units reduced, I will try smaller time. Okay, this is our yeah, let's do it now. Yeah, if already enough units reduced, as we mentioned, we will try smaller time. So answer here will be mid. Okay, and the right will be mid plus minus one. Right will be mid minus one, and the else here we can do, otherwise I will try larger time. So I will move left to mid plus one, and after that I will return the answer. Okay, yeah, let's now starting with test is the code. Yeah, let's run. Yeah, right, mid right, it is not correct. R G H T and remove this one. It's now correct, so we can submit it. Yeah, runtime error here. Let me check it. Yes, I think the error here happens because the calculation for right uses integer values, but the result is too large for an integer, specifically for max time factor, multiply and so on. So we need to redo making this is one like this one, static cast, long cast by this. Let's check it now. Yeah, I need to submit directly, sorry. Yeah, I think now it is okay. And yeah, I think that's all of my side. This is very simple problem. I hope to try it to by yourself. Yeah, thank you and see you next time. Bye bye.